Hey guys, today we're taking a look at vector and parametric equations of a plane. So, a plane can be determined by points and lines, okay? Points and lines. Alright, there are four main possibilities which can give us this. So in other words, what we require is 3 points here. We got 3 points. Okay, 1, 2, 3. If you have 3 points in 3 dimensions, that's enough to give you a plane. If you have 2 parallel lines, that's enough to give you a plane. If you have 2 lines that intersect at a point, that is also enough to give you a line. And finally, if you have 1 line and a point, that is enough to give you your plane. I think I said line there, whatever. All right, so here we go. So vector and parametric equations, this works the same as with lines, it's just a little bit more complicated. So the symbol we use to denote a plane is pi. Okay. Now, depending on the book that you use for this, it may be a capital pi, which is just a big pi. All right. Some books, I'm trying to think, I think some books will actually use a p or a lowercase pi. I just do a sloppy pi so that you could decide it's lowercase or uppercase, but whatever. Anyway, 2 vectors, u and v, are parallel to the plane, but not between them. So u and v are not parallel themselves, okay? So these would be called direction vectors, okay? Just like with a line, okay? So those are your direction vectors. Okay, and that's of the plane pi. There we go. All right. So the vector p0 to p from a specific point, just like in a line, we will need that specific point on the plane that goes to a generic point. Or sorry, here's my specific point. I wrote it as this: x0, y0. So that's that starting point. Just like with a line, but it goes to a generic point, which we'll just call P. Whoops, that's supposed to say generic. Generic point P, which we'll just call X, Y, Z. Okay? This is a linear combination. Linear combination of u and v, of these direction vectors. So in other words, I create a vector using those other 2 vectors. So it'll give us this point, which we won't actually call this because that's a long way to write it, but you're just taking that u vector and you're multiplying it by a number. It doesn't matter what the number is. And then we add the v vector also multiplied by a number, and again, it doesn't matter what that number is. So there, s and t are just any 2 real numbers. Okay, so we're creating other vectors using these 2 vectors, in other words. Okay, and by doing that, that creates a plane, and that creates the direction of the plane. But then, of course, we just have to give our starting value, which will then tell us where that plane is located. So the vector equation of a plane, and this is very similar to what we had with a line, is we're going to create any position vector by taking that starting value, okay, and then we're going to add that linear combination. Okay, so you'll notice it's exactly the same as the equation of a line, except that this time we have a second direction vector. Okay. So to do a parametric equation, again, it's exactly the same. We've still got x, we've still got y, we've still got z. Okay. Well, I guess it's just that there's a third term to calculating it. Okay, so we add s, I'm going to zoom in, try and make it a little less sloppy for you. Okay, plus t times v, the x component of v. Okay, then we got y0. I'm not sure why I wrote it so spread out here, but whatever. And then we've got the y component of v, and then we multiply, and then we've got our z. So z is z0 plus, oh, that's not right, the z component of u plus the z component of y, or of v. Okay, so there we go. And of course, you do have to specify that s and t are both just elements of the real numbers. Okay, so that creates our plane. All right, so here we go. Let's take a look at a couple. We'll start with some simple examples. So we got a plane pi, and it's given by this equation. So we need to find 2 points on the plane. Okay, well, the first point is easy, of course. First point, we could just use that starting point. Okay, so we'll say that there's our first point. Okay, and then our second point, well, if we go to our equation, we just have to let s and t equal something other than 0, because we've already got the one where they equal 0. So let's just let's let t stay 0. So we'll keep that one 0. And let's take this one and let's just let s equal 1. Okay? If we let s equal 1, then we're just adding on 1 to the z component. So a second one would be -1, 0, 3. Okay, but there's there's an infinite number of points we can have here. We just have to let s and t equal something other than 0, and it can be anything. It can be any real number. It doesn't even have to be an integer, and we're good. So the final line on this plane is actually even easier. Well, I think it's actually easier. Maybe you disagree. Okay, I'm just going to say, all right, well, let's take that starting value. Let's add the s times 0, 0, 1, where s is an element of the real numbers, and let's just ignore that t component. Let's ignore this second direction vector. And by doing that, it just gives us a line. Okay? We could alternatively have used that second direction vector, but it doesn't matter. There you go. So that's a nice, easy way to find one line on the plane. Okay? So this next one's a little bit more challenging. We're going to find a vector equation of a line that is perpendicular to this plane, okay, and passes through the origin. It passing through the origin, that's really not going to be that relevant until the end. It just means that when we add our starting point, we'll just use 0, 0, 0, so we don't have to actually worry about it. So, how do I find a line, or a vector rather? I need a direction vector is what I need here. And it needs to be perpendicular to both this and to this. So how do I find a vector that is perpendicular to 2 other vectors? Well, I just do the cross product, right? So I just say, what were my vectors here? So we got 0, 0, 1, cross, and that's a vector. 1, 0, -1. Okay, also a vector. I'm actually realizing I left out that guy. Anyway, so there we go. So that's all we need to do here. Okay, so what we'll do is we'll say, all right, then we're going to write. Remember, you start with your y, so we'll do the first vector is 0, 1, 0, 0. And then our second one, we've got 0, -1, 1, 0. Okay? And we go 0 times -1 is 0. 0 times 1 is 0. So the x component is going to be 0. Then we've got 1 times 1 minus -1 times 0, which is just 1. Oh, and then finally, we got 0 times 0 minus 1 times 0, which is obviously just 0. So our direction vector is just going to be 0, 1, 0. So if I'm going to write this as or it wants it written in as a vector equation. Hold on, let me try that again. That's pretty bad. So that's supposed to be the. Oh, that's why I'm writing it upside down. That's why it looks wrong. There we go. All right, so there's our line. So we're going to have R is equal to, okay? And our starting point, we're just using the origin, so we can actually just ignore it, and we can just say, and I'll use the letter Q because we've already used T, we've already used S, we've already used R, so we just have to use a new letter, so we use Q, 0, 1, 0. And that is Q, whoops, that's a G. I think I know my letters by now. Q is an element of the real numbers. And there we go. That's it. Okay. So I'm going to leave example 2 and 3 to you, and we will take them up in class. I'm actually also going to leave question 4 to you because I think that you should be able to get that. I'm going to jump to example number 5 because it's a little bit more tricky. Okay? Easy to make a mistake on example 5. So this is a case where I've given you your two direction vectors are parallel. Okay? Because I gave you two lines that are parallel. So when we go to use our point, it's easy enough, and we can use because we need remember we need a point and two direction vectors. So when we use our first point, we can just use either of these ones here. Okay? Either one will do. It doesn't make a difference. When we go to use our direction vectors, we can use one of these two, but we can't use both of them because they're collinear. So it would only give us a line. It would give us the equation of a line, not a direction vector. Or not a plane, sorry. Okay? So what we need to do is we need to create a direction vector, a second direction vector. And what we're going to do is we're just going to use these 2 points here, and we're going to find the vector that's formed from that. Okay, so let's say, so we'll use we'll go 1, and then we'll subtract the 3. Okay, and you could of course do 3 minus 1. It doesn't make a difference. I maybe should have because I'm realizing these are going to be negative numbers now. But once you start something, you got to stick with it. Okay, whoops, that's not even right though. That's supposed to be minus 0. So there we go. So that's going to be our second direction vector. I just subtracted the x components, the y components, the z components. Okay, and so I'm just left with negative 2, 1. And of course, if I had subtracted them in the opposite order, I would have gotten 2, 2, and negative 1, which is a vector that has the exact same direction, so it doesn't matter. Okay? But there's my second one. So now I can just say, all right, so pi is r equal to, and we use our first point, and again, it doesn't matter which one you use. I'll use the 1, 2, 1. Okay? And then I say plus, and we say s, and I use one of those two. I'll use the one with the positive numbers just because I like positive numbers. I am an optimist after all. Okay? And secondly, we need our remaining one, okay, which was negative 2, 1, the one we created, okay? Negative 2, 1. And there we go. So that's all that's left is we just have to say s and t are elements of the real numbers. And we are solid. So there you go. All right, so I want you to try the remaining questions on your own as well, and we will take them up in class. So until next time, go Sabres.